Are you interested to know that how much amount of money will you get after 3 years at an initial investment of 1200 rupees? Will your answer be different if you invest 400 rupees in year 1, 400 rupees in year 2 and 400 rupees in year 3, assuming the interest rate as 10% per annum in both the scenarios? A very good afternoon to one and all. Myself Dr. Rishabh Gupta, and in today's session we will be understanding a prominent component of time value of money, that is compounding techniques. So compounding techniques works upon a concept similar to compound interest rate, and it includes future value of single cash flow and the future value of series of cash flow, which again include equal cash flows and uneven cash flows. So simple interest rate is basically dependent upon three components: principal amount, interest rate per period, and the time period for which the principal amount is borrowed or lent. The simple interest is calculated based upon the principal component only. By putting it into the formula for simple interest is principal amount multiplied by interest rate multiplied by time period. And the amount of money which you will get after a specific time period will be equal to principal amount plus simple interest rate. Let us take a small example. If I am saying that I have invested 100 rupees in a saving bank account at a simple interest rate of 10% per annum, the time period is 3 years. So based upon this information, my time period is 3 years, principal amount is 100 rupees, and the rate of interest is 10% per annum. Now putting all these information in a formula, your simple interest comes out to be 100 rupees multiplied by 10% multiplied by 3 years, that is 30 rupees. And the amount of money which you will get after 3 years will be 100 rupees plus 30 rupees, that is 130 rupees. But simple interest has a very limited application in the field of finance. What is more prominent in the field of finance is compound interest. So compound interest is also known as interest on interest, wherein the interest is earned on the principal component as well as the accumulated interest amount. Let us again take the same example. Mr. Rohan has invested 100 rupees at a compound interest rate of 10% per annum for a time period of 3 years. Now in such scenario, you need to calculate that how much amount he will get after 3 years. So the 100 rupees invested will become 110 rupees in year 1, 121 in year 2 and 133 in year 3. How we have calculated? 100 rupees multiplied by 1.10 will give you 110. 100 rupees multiplied by 1.10 raised to power 2 will give you 121. 100 multiplied by 1.10 raised to power 3 will give you 133 rupees. So the 100 rupees invested will become 133 rupees after 3 years, assuming the compound interest rate as 10% per annum. Putting it into the formula, the amount of money which you will get after compounding is principal amount multiplied by 1 plus I raised to power n. And the compound interest will be equals to 1 plus p multiplied by 1 plus I raised to power n minus p. Based upon this information, you can calculate the amount invested. Now let's understand the difference between a simple interest and a compound interest. If rupee 1 is invested, then it becomes 1.07, 1.70 after 10 years and 8 rupees after 100 years. However, in case of compound interest rate, if you have invested 1 rupee, then it will become 867.71 rupee. This shows the power of compounding. Now the question is that which one is more prominent? As I already told you that simple interest has a very limited application in comparison to compound interest. Also, the interest which you earn in your saving bank account, the interest which you earn in your post office saving bank account, or on your certificate of deposits or treasury bills, all are the examples of simple interest. However, the interest which you earn on the public provident fund, Kisan Vikas Patra, and many such schemes are the examples of compound interest. But now the question is that which one is more beneficial? So it again depends upon that whether you are a borrower or a lender. If you are a borrower, then for you interest is a cost. And if you are a lender, then for you interest is a income. So from the borrower's point of view, it will be beneficial for him or her to go for the simple interest like arrangements, wherein the interest cost is comparatively lower. However, from the lender's point of view, it is better to go for the compound interest like arrangement. Same goes for the investor as well. The investor whose objective is to maximize the return must always look for those instruments that have the compound interest like arrangement. So this was the basic difference between the simple interest and the compound interest. Let's move our discussion on the concept of future value of single cash flow and the series of cash flow. So if a person is making a one-time investment and he is interested to know the future value of that investment after a specific time period, then it's a case of future value of single cash flow. Let us again take a small illustration. If I am saying Mr. Rahul has invested 1000 rupees for a time period of 2 years at a compound interest rate of 7% per annum. Now based upon this information, now if you have invested 1000 rupees for a time period of 2 years, then it will become 1070 rupees in year 1 and 1145 rupees in year 2. So this 1145 is the future value of my one-time investment, that is 1000 rupees. Now this 1145 includes 4 major components. 1000, which is my principal amount. Rupees 70 is the interest which you have earned in the first year. And 75 rupees is the interest which you have earned in the second year. So this 75 includes 2 subcomponents, 70 rupees and 5 rupees. That is the interest which you have earned in the second year and the interest on interest. So in my illustration, I have told you that the interest rate is 7%. So 7% of 1000 gives you 70 rupees in year 1 and 7% of 1000 will give you 70 rupees plus 7% of 70 rupees, which is 5 rupees. The total comes out to be 75. So this shows the power of compounding. The process of generating return on investment over a time period is known as compounding. Now under future value of single cash flow, the formula is future value is equals to present value multiplied by 1 plus I raised to power n. However, in order to avoid the mathematical computation, we have a shortcut formula. Future value is equals to present value multiplied by CVIF IN. Now what is this CVIF represents? CVIF means compound value interest factor. This is a table in the form of matrix wherein the interest rate are on the top side and the time period is on the left side. If I am saying my interest rate is 10% and the time period is 9 years, so the value comes out to be 2.358. What does this indicate? It means that if I have invested 1 rupee, then the invested amount of 1 rupee will become 2.358 rupees after 9 years, assuming the interest rate as 10%. By looking at this table, one thing you can notice that with the increase in the time period, the value increases at a given interest rate, say 10% in this case. So it indicates that longer the time period, higher will be the future value. Similarly, at a period 9, you can notice that the value becomes 1.094 to 1.305, 1.551 and so on and so forth. So with the increase in the interest rate, the future value also increases. So there are two things which are clear. Number one, longer the time period, higher will be the future value at a given interest rate. Number two, higher the interest rate, higher will be the future value at a given time period. This shows the power of compounding. This is again a graph which shows that with the increase in the interest rate from 5% to 10% to 15%, the future value increases. Also at a given interest rate, say 15%, with the increase in the time period, your value increases. Now the next component under compounding technique is the future value of series of cash flow. Under future value of series of cash flow, we have an important concept that is called annuity. The definition of annuity is that it is a finite series of equal cash flows occurring at a regular and equal interval. Let us take a small example and then we will understand the definition again. So the formal definition of annuity is that it is a finite series of equal cash flows occurring at a regular and equal interval. Let us take this scenario 1. If I am saying that I am investing 1000 rupees in year 1, again 1000 rupees in year 2, year 3, year 4 and year 5. This is a perfect case of annuity because my cash flows are equal, that is 1000 rupees. My intervals are equal since I am investing 1000 rupees in year 1 and again 1000 rupees in year 2. And also my cash flows are finite, which means, so there are three subcomponents. Cash flows are equal, cash flows are finite, and they are occurring at a regular and equal interval. So this is a case of annuity. Second scenario, if I am investing 1000 rupees in year 1, again 1000 rupees in year 2, zero investment in year 3 and year 4, and 1000 rupees in year 5. Now in this case, although my cash flows are equal, but my intervals are not equal. My cash flows are finite, cash flows are equal, but the intervals are not equal. So it is not a case of annuity. Scenario 3, if I am investing 5000 rupees in year 1, 6000 rupees in year 2, 5000 in year 3, year 4, and at last 4000 in year 5. Now in this case, although my intervals are equal, cash flows are finite, but my cash flows are not equal. So this is also not a case of annuity. The last scenario, wherein my cash flows are equal, that is 1000, my intervals are also equal, but my cash flows are infinite. So we don't call it annuity, there is a different term that is called perpetuity. If I am saying that Mr. Rahul has invested 1000 rupees for 4 subsequent years at an interest rate of 10% per annum, which means Mr. Rahul is investing 1000 rupees in year 1, 1000 rupees in year 2, year 3 and year 4. So this is a case of annuity and I need to calculate the future value from that investment. Now if Mr. Rahul is investing 1000 rupees at the end of year 1, then this amount will remain invested for the 3 years, that is 2, 3 and 4. So I need to calculate the future value. Now in this case, if I am investing 1000 rupees at the end of the year 1, this amount will remain invested for the remaining 3 years. So it means annuity multiplied by CVF 10%, 3 years. So the future value at the end of the 4th year will be 1331 plus 1210 plus 1100 plus 1000. This will give you 4641. So it means if Mr. Rahul is investing 1000 rupees in the form of annuity, assuming the interest rate as 10%, then it will become 4641. This is a long cut procedure. However, if my cash flows are not in the form of annuity, if they are unequal, then I need to follow the same procedure. However, if they are in the form of annuity, then we can also adopt a shortcut formula. Future value is equals to annuity multiplied by CVAFIN. So if I am saying the time period is 4 years, the interest rate is 10%, the value of CVAF comes out to be 4.641. So 1000 multiplied by 4.641 will give you the same amount. So in my example, I have told you that the sum of the future value is equals to this amount plus 1210 plus 1100 plus 1000. I can rewrite in this way also. Now this is forming a series, annuity plus annuity multiplied by 1 plus I, annuity multiplied by 1 plus I square, and so on and so forth. Now by looking at this series, we can find this is a geometric progression wherein the first term in case of geometric progression, we know that the first term is A and the common ratio is 1 plus I in this equation. Now, the formula for the sum of geometric progression is in case of sum of geometric progression, the formula is A multiplied by R raised to power n minus 1 R minus 1. My A represents the first term and R represents the common ratio. Now putting this information in my equation, A is annuity capital A and the R, which is the common ratio, is 1 plus I. Now putting this information into this formula, A multiplied by 1 plus I raised to power n minus 1, 1 plus I minus 1. By rewriting it, it becomes A 1 plus I raised to power n minus 1 divided by. So in case of future value of annuity, this is the formula. The shortcut formula is annuity multiplied by CVAFIN. Now this is my CVAF table. Again, the table represents the same thing. Higher the interest rate, higher will be the future value at a given time period. Longer the time period, higher will be the future value at a given interest rate. So that's all for my side. We'll meet you in my next session. Have a nice day.